Hey, sixth grade mathematicians, welcome back. So today we're going to continue our discussion about area. Now last week we talked about area, the area of a parallelogram, and we talked about the area of a right triangle. And we're going to continue on talking about triangles and the area of triangles, but we're going to take a little different twist with it. First of all, let's go ahead and review, and I'll tell you where we're going from here. So before we start, there is a paper that looks like this that you should have copied off, and I would like you to go ahead and cut out this triangle. We're going to need that in the lesson today. If you haven't done that, please go ahead and pause the video and do that, and then come back and we'll be all ready to go. So we're going to start our discussion where we left off last week. And I've got two triangles here, and one of them I noticed that they're different. I noticed right away that they're different. I noticed that one triangle has a right angle. Right angle is right here. Now, I can say a few things about this triangle now. I can say that it has a 90-degree angle, or square corner. I can also say that it has a perpendicular line to the base. How do I know it's a perpendicular line? Because perpendicular lines create a right angle. So I know that this is perpendicular. That word is going to come up quite a bit in this lesson. So I hope that you wrote that down last week, because when you write things, you're more likely to remember them. So this is a perpendicular line to the base. I also know that this is the base and this is the height. And I know by looking at this, this is a right triangle. So there are several things that I could say about this triangle just by knowing that this is a right angle. Now I'm taking a look at this triangle. Now this triangle is different. This triangle does not have any right angles. In fact, all of the angles here are less than 90 degrees. So what do I know about an angle that's less than 90 degrees? I know that it's an acute angle. So the name of this triangle is an acute triangle. Or that's one way to label this triangle. There are other ways to label this triangle, but for our purposes here today, that's what we need to know. All right, so we know how to find the area of this right triangle. We have half base times height. And we know that that gives us the area of the triangle. But if there's no height, like here, we don't have any perpendicular line. We don't have the height. So how are we going to figure out, how do we calculate the area of a triangle that does not have a height? What we're going to have to do is we're going to have to draw a perpendicular line from a vertex to the base. And that's what we're going to use. It's also, when it's on the inside of the triangle, there's another name they can call it. They could also call it the altitude. All right, so if we create a line from a vertex, which is right here, to the base, we can create a perpendicular line. Whoops. And now when we take a look at this, we have a right angle. Actually, we have two. We have a right angle on this side, and we have a right angle on this side. So I have created two right triangles. So from those right triangles, we can figure the area of this side, then we can find the area of this side, and add them together to get the area of the whole triangle. So we'll have a base on this side, a base on this side, and you'll notice, I could draw a little dotted line right here. This is where it would stop. The base for the first triangle would stop. This is where the base of the second triangle would begin and end. So you have to keep that in mind. So if you have a total of 12, that does not mean you're going to use 12 for the base here and 12 for the base here. You've got to be careful with that. Now, the height would be here for this side. The height would be here for this side. but the numbers would be the same, obviously, because you're measuring the same line. So you're going to do half base times height here, half base times height here. The answer that you got for both of those, you're going to add them together and use that to find the area of the whole triangle. All right, so I hope that makes sense to you. We're going to be playing around with that, working with that some more. So for right now, I'm going to erase, and I'm going to revisit the triangle that I asked you to cut out. So I've got that triangle right here, and I need to get another piece of tape here. All right, so I've got that triangle cut out, and I'm noticing right away that this is not a right triangle. There is no line that is perpendicular to the base. All right, so I know that I'm going to have to create a line, a perpendicular line to the base. So again, I'm going to get my straight edge, my ruler, and I'm going to create a line from the vertex to the base. All right, so now I have my altitude or my height. So I'm going to pick this up, and I want you to pick yours up, and I want you to fold it on the line so that you can see visually that these are two right triangles. So I can take a look at the one side, I can flip it over like this, and I can see that this is a right angle, and it is perpendicular to the base. I can also flip it over like this, and I can tell here is a right angle, and that it is also perpendicular to the base. So I have created the two right triangles that I need in order to find the area of this triangle. Okay, so now what do I know? I know that half base times height gives me the area of a right triangle. So this equals the area. So now, how am I going to find that? Well, I need to measure. So I've got to get my ruler out and measure the base. Now remember, I told you for the base, we need the base. For the first triangle, the base is going to stop right here. So when I'm measuring, I've got to measure carefully, and I notice that the base is 4.5. My base right here is 4.5. 4.5. All right, so now I have to measure the height or the altitude, and that is 3. So 3. So now what I need to do is I need to plug those numbers in to the formula. So I've got half base, which is 4.5, 4.5 times the height, which is 3, and that's going to give me the area of this side. So half of 4.5 would be 2.25 times 3, and that would give me 6.75. So 6.75, I know it's in inches, I measured in inches, and it's area, so it's inches squared. All right, so I have found the area of this first right triangle. Now I've got to do the same thing with the other side, but I have to measure the base for this side too. So I've got 1.5. 1.5. So again, I need half base, which is 1.5, times height, which is 3. So half of 1.5, I can think of that as in money. Half of $1.50 would be 75 cents. times 3, and 0.75 times 3 would be 2.25. And that again would be inches squared. All right, so now I have found the area of this right triangle and this right triangle. I have not yet found the area for the whole thing. So in order to do that, I'm going to have to add them together. So I'm going to have to add 6.75 inches squared plus 2.25 inches squared, which is going to give me a total of, now I've got 6 plus 2 is 8. 75 cents plus 25 cents is another dollar, which would be 9. So that would be 9 inches squared. All right, so that gives me the total area of the triangle. So if you notice, I used the area of a right triangle for both sides and then put them together to find the total area. So if you have any questions about that, you can email me. Tomorrow we're going to do the exercises with the classwork, and that's going to give us a little more in-depth involvement with this formula for the area of a triangle. And so I want you to have that copied off when you come tomorrow. Keep thinking, keep watching, always stay curious. I'll see you tomorrow.